Good evening, everyone. So let's start today's session. So welcome all of you for the today's second live interaction session on MATLAB based programming lab in chemical engineering. So for those students who are new or who are joining for the first time for today's session, let me give you my short introduction. So myself, Prasil Kapadia, and I have completed my BTech in chemical engineering from SVNIT Surat in 2019. After that, I joined Reliance Industries Limited at Jamnagar location, and I worked there for 1 year, mostly on S-Pen. Then I joined IIT Kharagpur for my master's course. During my master's, I learned this course MATLAB by same professor, Professor Parag Deshpande. He taught us this course, not same course but similar course. And then currently I am a PhD student and at IIT Bombay. So this is my web page and this is my LinkedIn page and this is the YouTube link where you can see all the live interaction sessions videos. Those videos will be uploaded there. So let's get started with today's session. So in today's session, sorry, just a minute. For today's session, we will be mostly learning the way Sir has taught how to write a code. So for that part, today we will be taking one example of how to calculate the factorial of a given number. So we have learned these things during our BTECs and even in 11th, 12th that how we can calculate factorial of a number. So let's say I want to calculate factorial of any number. Let's say I want to calculate factorial of 1. So factorial of 1 is calculated as 1 factorial is equal to 1. Factorial of 2. So 2 factorial is calculated as 2 into 1. Similarly, if I want to calculate 3 factorial, it is 3 into 2 into 1. 4 factorial, it is 4 into 3 into 2 into 1. So in this process, what is common? We are starting with 1. If we are seeing here, we are ending at 1. But let's think it reverse that we are starting with 1 into 2 into 3 and we are multiplying it till our wanted number. Let's say I want to calculate factorial of 5. So I will stop at 5. Let's say I want to calculate factorial of 8. So I will calculate it. I will stop at 8. So I will start my multiplication from 1 into 2 into 3 and I will stop at the number for which I want to calculate the factorial. So let's say I want to calculate factorial of n. So how will I calculate n factorial? 1 into 2 into 3 into I will stop at value of n. So this is the general way of calculating factorial of any number. Let's say I want to convert this calculation part into one MATLAB code or in any general code. So what can be the any pseudo code to convert this factorial into factorial of a number? What will be the pseudo code? Can anyone tell me? Today no one has joined, only one student. If you want to say how can you calculate the factorial of a number, any basic rough idea for the code? Okay, something is written. Slides are not seen. Oh, sorry. Okay, I guess now slides are seen. So this, okay, I'm sorry for that. So this is the first slide, and this is the second slide of my introduction and the links of web page, LinkedIn, and YouTube. This is the link where you can follow the lectures. So, okay, I will repeat whatever I did. So to calculate any factorial of a number, I guess my screen is visible now. So let's say I want to calculate factorial of 1. So factorial of 1 is calculated as 1 factorial is equal to 1. Factorial of 2 is 2 into 1. 3 is 3 into 2 into 1, and 4 is 4 into 3 into 2 into 1. So what we are doing, we are starting from the number, the number of which we are willing to calculate a factorial, and we are going till multiplication of 1. So let's think it in reverse way, that 4 factorial is 1 into 2 into 3 into 4. 3 factorial is 1 into 2 into 3. 8 factorial will be 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. And similarly, n factorial will be, we will be multiplying our number till n. So to calculate any factorial, what we need to do, we need to start from 1 and we need to multiply till that number n. So can anyone tell me what is the pseudo code for that? Not an actual code, but what is the pseudo code to calculate factorial of any number? We need to start from 1 and we need to stop at any number, not any number, but the number for which we want to calculate a factorial n. So we need to start from 1 and we need to stop at n. So I I will show. So first, let's say, let's forget this right hand side part for now and let's focus on left hand side part. So what we have to do, we have to start from, let's say, I is equal to 1. So that is my first point, I is equal to 1. And let's say I want to stop at n is equal to 5. So what I will do, I will write a, first let's see using while loop. So what I will do, I will write while I is less than equal to n. Means I have to start from 1. What is less than equal to mean? 1 less than equal to 5. Sorry. 2 less than equal to 5. So when we are at point number 5 end point, so it will consider that 5. So 5 is less than equal to 5. So till here, factorial will be calculated. So while I is less than equal to n, factorial is equal to factorial into I. So what we are doing, we are giving initial value of fact as 1. So what it will do at, what it will do when I is equal to 1, it will do 1 into 1. So that will be here, it is 1 into 1. And at this at this step, what is my initial value of I? Now it is I plus 1. So that I has converted into, sorry, I is now 2. For now, then we will go here again. Is 2 less than equal to 5? Yes, 2 is less than equal to 5. So what it will do now? Factorial is equal to factorial into I. So my factorial value is, initially what was the last value? 1. So it will be 1 into 2, my new factorial value. And after that, my I will be 2 plus 1, 3. It will again go here. 3 is less than equal to 5. Yes, 3 is less than equal to 5. It will again calculate factorial. Factorial is equal to factorial into I. This was my previous value of factorial, 1 into 2. Now what it will do, it will multiply with I, that is 3. Again 3 plus 1, 4. And if 4 is less than equal to 5, yes, 4 is less than equal to 5. So it will be multiplying this value of factorial with I. So I is my 4. Then go to next step, I plus 1. My now I is 5. Now if phi is less than equal to phi, phi is equal to phi. So this condition is satisfied. So my old factorial was 1 into 2 into 3 into 4. I am multiplying it with I. So I is my phi. So now I is phi, I is equal to I plus 1. Now value of I is 6. So what it will do, it will go here. I is less than equal to n. 6 is less than equal to 5. No, 6 is not less than equal to 5. So it will stop at this point. So it will not move. Code will not move ahead. Did you understand the code? Did you understand the code? Whoever has joined. Hello. Please, can anyone respond? So what we are doing? What we are doing? we are doing 1. Let's say my n is equal to 5. What we are doing, we are writing a while loop, while, and we are starting I is equal to 1. So where while I is less than equal to n. So when my I is equal to 1, 1 is less than equal to 5, what it will calculate? Factorial is equal to factorial into I. So my initial value of factorial, I need to start with some point. So 1 is the best point to start. So my factorial will be at 1 is less than equal to 5. Let's not take 5, let's take 3 for now. So 1 into 1, my factorial value. And I what I need to do now? I need to increase my value of I by 1. So I will write I is equal to I plus 1. So my new value of I is 2. So it will again go to while loop. 2 is less than equal to 3. Yes, 2 is less than equal to 3. It will calculate factorial as my initial value was 1. So now my new value is fact into I. My I is 2. Now I is plus 1, that is 3. Similar thing, 3 is less than equal to 3. Factorial is 1 into 2, earlier value. Now it will multiply it with 3. And my I will be I plus 1, that is 4. So at 4, we need to stop our loop because the condition is I is less than equal to n. So can we write down this thing in MATLAB? Can anyone respond, please? Let's write this while loop. You don't have to write this code for now, but let's understand how we can write this code. So my MATLAB is opening. I hope you all got the license for the MATLAB. So I'm writing on live script. I don't need to save it. So what I will do, I will take I is equal to 1. I will put a semicolon. Why do we put semicolon? Why do we put semicolon? To suppress the unnecessary information. This I is equal to 1 won't be showing in this command window when we run the code. So this is the live script that I have chosen from here. Sorry, from here. So this live script, I don't really need to save it in my system. I just want to write and I want to run it. So I have started with I is equal to 1 and fact is equal to 1. Now what I am doing, I am using a while loop. So while, and I would need to put some value n. Epsilon n is equal to 10. So what it will do while n is less than equal to. So in MATLAB there is when you used to use you want to write less than equal to, how do we write in normal maths? We write it like this: n is less than equal to this symbol. But here in MATLAB, what we do, we first put the symbol of less than and then we put equal to. When I is less than equal to n, what it has to do when I is less than equal to n, it is calculating fact is equal to fact into I. I will put one semicolon because I don't want to see what is being done. Then I is equal to I plus 1 and n. Okay, so let's run this and see what we are getting. So see here, I can in this workspace, you can see here, I can see the value of n is equal to 10. I is equal to 11 because last value of I will be here when I is equal to 10. It will calculate factorial of 10 into fact into 10 and it will increase I by 1. So it will be 11, and when it will go to again this while loop, the loop will be broken and we will be getting factorial is equal to whatever is the value 3628800. We can also do one thing. Instead of running this whole code in whole part, let's say I'm just keeping value of 3 and I want to do it stepwise. So what it will do, it will show us whole execution step by step. I will press continue. Sorry, I will press first step. So it is first executing step line. So what is step line? Whatever is here in command window. Let's say I'm writing something in command window. 4, 5. Okay, so what it will do? Let's say I'm doing step. So it will clear all. Then CLC. So this CLC, this window is cleared. Then it is going to the fourth line. So what is fourth line saying? I is equal to 1. So see, I is equal to 1 is stored on workspace. Then I am again pressing step. So what it is taking, fact is equal to 1. So it has taken fact is equal to 1. Then what it should take, n is equal to 3. Now it will check this condition, I is less than equal to n. So here 1 is less than equal to 3. So this is correct. So it is calculating fact is equal to fact into I. So what should be the value of factorial? It should be 1. And what is the new value of I? You can see here, new value of I is now 2. But it won't end, because when value of I is 2, it is again going in this loop. I is less than equal to 2. So it will again calculate factorial. Factorial will be 2 into 1, that is showing as 2. And I is my 3 now. Again it will go, you can see here in workspace, the updates, those are shown. So when I is equal to 3, my factorial is showing as 6. Sorry. And now my value of I is 4. So what it should do, it should now end. Right? It has ended. It's not executing. So this is how you can stepwise run your code. So this is mostly useful to do this stepwise operation when uh, when you are having some kind of errors in your code and you are not able to understand what is the error or how to execute error. So for that kind of case, it is advisable to run your code stepwise, so you can understand if you have done any mistake in writing this formula or something else. So at that point, this stepwise execution is useful. Is while loop clear to everyone? How we wrote a code for factorial of a number using while loop? Okay, no one is responding. I assume that it is clear to everyone. So let's see how we can write this same thing using for loop. Before that, let me clear this thing. Oh, it's not getting clear. I don't know why. Yeah, it's done. So let's see how we can write our code using for loop. For loop is a bit easier to execute. So for loop, what I need to do in for loop, I am telling that I need to run from I is equal to 1 to any end. So we don't need to really give this I is equal to I plus 1. It will automatically increase the value. Let's say I am writing 1 is to 5. So it is one when I wrote 1 colon 5. What it does, it creates from 1 to 5 equal length of 5 points. 1, 2, 3, 4, 5. Let's say I write 1, 1, 5. So it creates, we don't need to here really mention in. I hope you remember this when I taught this. Let's say I want to create between 0 to 1, I need to create 10 points. So I will write, sorry, 0 to 1 in interval of 0.1. So how I will show it like this: 0 colon 0.1 colon 1. So what it will do, it will create between 0 to 1, it will create points in interval of 0.1. You can see these on the screen: 0, 0.1, 0.2, 0.3, like that. So let's say I want to create from 1 to 10 in interval of 1. So I will write it as 1 colon 1 colon 10. So what it will do, it will create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you are doing it in increment of 1, you really don't need to mention this between part in gap of 1. It will automatically understand that we are creating our points or vectors in interval of 1. So this is something similar we do in for loop. We define the value of I is equal to 1 and n is equal to 5. So here what we do, we write for I is equal to 1 to n. So what do you mean by 1 to n? For I is equal to 1 to 5. So when we are not mentioning or specifying the interval, what it will automatically do, it will run from 1 to 5 in interval of 1. So from first it will run for I is equal to 1, then 2, then 3, then 4, then 5. And then it will automatically stop. So say here my I is 1. So 1 I is my 1. So factorial is 1. Fact is 1 and I is 1. Then it will again go to here. My new value of I will be now 2. As it is 1 to n, so 1 to 5 in interval of 1. So it is 2 now. So my factorial is 1 into 2. Then it will again go. Now value of I is 3. So here it will be multiplying with 3. Then again it will go up 4 into 4 and 5 into 5. So here 4, when we are using for loop, we really don't need to mention this thing. I is equal to I plus 1. It will automatically increase that number by it. This I is equal to 1 to n will automatically take care of that part. So let's try to write down this code using for loop. Students, just give me a minute. So let's try to write it down using a for loop. So I am creating one new live script. Let's do the similar thing. Clear all CLC. Then what I will do, I will write I is equal to 1, fact is equal to 1, and n is equal to 5. Or I is equal to 1 colon n. So 1 to 5. Let's say I am writing it in this way. Fact is equal to fact into I and end. So see, this is what one interesting thing taught by Parag sir. When we are writing any loop, we should use this indent, and this loop while and end, it is on one side and the content is on another side. But see here, I have not written it like that, or you have not written it for the long code like that. So what you need to do, you just need to select the code, and there is one option of smart indent here. If you click here, it will automatically take care of that. If you somehow forgot to do it, or if your code was really long and you forgot to do it, so instead of doing everything manually, you just need to select select your loop, right click it, and you can where did it go, smart indent. Yeah, you can just click here, so it will show it like this. So see, our code is ready. So let's run it. So see, it is showing the correct value of 120. So here, what it is doing, let's again see stepwise. For I is equal to 3. First, it is clear all. Oh, sorry, clear all. Then CLC, we don't need to really worry. So see, I is 1. It is storing I is 1. Now, fact equal to 1, it's storing. N is equal to 3, it is storing. Then this thing, fact is equal to fact into I. So my fact value is 1. It is going again. Now my fact is 2. It is going again. Now my fact of 3 is computed. And my n is also 3. So it should stop here. There is no n is equal to 4. So it is showing down arrow, meaning our code is correctly executed. Okay. So is this clear to everyone? Whoever is paying attention, is this clear to everyone how we can write on small code? Okay. Let me play with one thing. Let's say I am writing n is equal to 0. So what should I get answer? What is 0 factorial? Can anyone tell me? What is the value of 0 factorial? What is the value of 0 factorial? You know it.
1.
Yes, 0 factorial is 1. So let's say I am putting n is equal to 0. So n is equal to 0. But it is showing n is equal to 0, 1. Can we find factorial of a negative number? No, we can't find it. Let's say I'm writing n is equal to minus 45, minus 4. It is showing fact is equal to 1. So this is something wrong. Or let's say, let's go to this code, and let's say I am writing n is equal to minus 4. It is showing fact is equal to 1. So is this correct? Can we really get factorial of a negative number? Or first, can we get factorial of a negative number? No, we can't get factorial of a negative number. So how can we improve our code now? We have already written our code. So how can we improve this small code? What are the improvements that we need to do? When my n is equal to 0, it should just give me value 1. We don't need to run this loop. And when there is a negative number or someone is trying to calculate the factorial of a negative number, it should show some message that your factorial of negative number is not possible. Can anyone suggest any other improvements in this code other than these two? Are there any other issues? When we are calculating factorial, we can't calculate it of negative number. And one definition for 0 factorial is 1. Anything other than this, we need to improve or we need to include in our conditions. Okay, let's take these two conditions and let's try to improve our code. So what I need to do, I will show it using for loop. So what we need to do, that when my n is less than 0, that then return some error, that is factorial is not defined for any negative number. Then this else if. What is else if? So let's say I am having multiple conditions in my loop. Let's say for this case, there are multiple conditions. Correct. That add page, let me add the page. Yeah. Let's say one condition is if n is less than 0. My another condition is if n is equal to 0. And anything other than that, we will calculating factorial. So we need to include two if loops. So how we can do it? For that, we need to use if n is less than 0, we will write something. Then there is something called else if. It's not completely else and it's not completely if. Then we will write n is equal to 0 some condition, and anything other than this, we will use simple else condition. Okay, so this is if else if loop. So let's try to search about that in MATLAB help section. So I'm writing here else if. Just wait for a couple of minutes. If else if s else. So see if some expression, then statement, else if again some expression, statement, and then else and last statement. So see here one example is given. If r is equal to c, some statement, else if this something statement, else this statement. So we need to use something similar like this. So how can I modify it in my code? So what I will do, I will write one if loop. If I is less than 0, what I need to write when my I is less than 0, what I need to show, I need to print that error is input must be a non-negative number. Okay. Else if, okay. So here what we are doing, we are comparing value of, sorry, not I n. Here what we are doing, we are comparing the, okay, here what we are doing, we are assigning value of -4 to n. But here, if I write n is equal to 0, what it will do? It will assign the value of 0 to n, but we don't want to assign, we want to check. So for that, we will be using double equal symbol. So when we are using equal to, it means that it will check that if n is equal to 0 or not. So if my n is equal to 0, so 0 factorial is 1. So we will simply put sorry, fact is equal to 1. Now you can see this red below F. There is one red color symbol. So what does that mean? If you click there, it shows that an and might be missing, possibly matching if. And here also for else if it is showing if and is missing. So what we should do? We should put one and here, one and here, and we don't need now for loop. We will just write here else. Fact is equal to fact into I, and we can put our this loop here for I is equal to 1 to n. Here we can put it, and our all here there is showing some. Okay, it's not an error, it's a warning, and we can ignore it. Now I need to smart indent it. So what I will do, I will select my whole loops. I will just press right, and I will choose smart indent. So see, this thing is done. I guess else if like this is also fine, or if you put the space between else and if, that is also fine. Okay, when I am writing it like this, it does not need an and, but if I'm writing like this, I need to put one and. So let's write it like this only, else if. There is no space between else and if. So let's run it and see what is my input. My input is n is equal to -4. So I'm running it. Oh, sorry, we need to put it here. Oh, sorry, this for loop will be here. Here we are calculating factorial, so that's why here. Okay, let's run it. One end is here. Yeah, we don't need this end. Yeah, yeah. Smart indent. Okay, what was the issue? When I these two parts are just to check the conditions. If and else, if anything else, we need to do it for I is equal to 1 to n. So we need to keep it here in the loop. So now I will this. So it is showing input must be a non-negative number. And what is our input? -4. That's why it's not showing the factorial of a number. Let's say I'm doing with n is equal to -10. It should show the same thing, that input must be a non-negative number. Let's say I'm showing n is equal to 0. So it is showing factorial is equal to 1. Let's say I'm showing 80. 80 is a huge number. So it is 7.1569 into 10 is to 118. So this is how you can calculate the factorial of a number. Okay, is this clear to everyone? How we can calculate factorial of a number with improvisation, given by adding some conditions that n is less than 0 and n is equal to 0. So this is how we can calculate factorial of a number. This is really an easy code, but I'm doing it really slowly just to make sure that you understand it. And you don't need to worry about writing part. You are, I guess, for this week, what is being taught for this week? Can anyone tell me? For week 3 content? Okay, it's fine. So this is about how we can calculate factorial. Okay, so there is one MATLAB inbuilt command for calculating factorial. So that is factorial of, let's say, 2. It's not, I guess, factorial. Let me check it. Uh, Factorial I am writing here. So what is the inbuilt MATLAB command is only factorial. Okay, f is equal to factorial of n. Okay, it's not supporting in my system. Let me do it here. Factorial of 2. And let's say I'm running it. Okay, in my system, I'm not understanding why factorial is not supported. I don't know why, but this is the way you can actually easily calculate the factorial of a number. Execution of script factorial as a function is not supported. Okay, let me just check one thing. Yeah, it's working, but factorial is not working for my case. But you can calculate factorial like this. Or I have given, oh yeah, because I have written one function. Wait, let me do one thing. Why it's not working, I understood it. Okay, now let me write factorial of, so see it's showing 2. Wait. So let's say I'm right. I want to find, you really don't need to write this code. There is MATLAB inbuilt command, command factorial. So when you call factorial, you just need to write factorial and in bracket the number for which you want to calculate a factorial. So C factorial of 10. Let's say I want to calculate factorial of 0. It should be 1. I'm trying for negative number. Say -9. So it should throw and must be an array of real non-negative integer. Here there is one more part of real integer. So let's say I want to find it for 1.5. So it should not show because it's not an integer. So this is what we can also include in our code to modify it. So this is MATLAB inbuilt function, but let's say we have already written this code. So this is code, and every time what I need to do, I need to change the value of n. So instead of doing this, what is the way of doing it in general way? What can we write? We can write it as a function, correct? So let's say I want to write a function that calculates the factorial of a number. So every time when I want to calculate the factorial, I really don't need to change it from here. So let's write one function. So how can I write the function? So when we are writing the function, let's make sure that we don't give the name of the function as factorial, because factorial is already one inbuilt function in MATLAB, else it will show an error. So let's write it down as a function. Let's say function fact is equal to factorial. Okay, before doing that, let's copy this code from here to here. And in our function, we don't define n, and it will be user input. Okay, so my function is function. What is the function for? Function is for calculating what value? Factorial value. So what we are calculating FACT fact variable. So that should be here. Function fact is equal to, what is the name of the function? Let's say my function name is find factorial. Find underscore factorial of what number? This value. Factorial of this n. So n. Okay, and I need to end my function. And let's do this. Let's use this smart indent. Where did it go here? Okay, it's already smart. So I have written my function, and let's say I want to calculate my factorial of a number. So what I will do, I will call this function. The name of the function is find underscore factorial. And let's say I want to calculate factorial of 5. Okay, and I will just run it. So see, it is directly showing 150. So let's say if you are having a huge code and you want to calculate some values at any intermediate. Let's say you want to calculate factorial 100 times in a code. So it is not advisable to write this code 100 times, but instead of doing that, we can write it as a function, and we can just call it when we want to call it. Let's say I want to find something really complex. Say I want to find 5 factorial divided by 4 factorial into 2 factorial, or 5 factorial. This seems really small number, but let's say I want to calculate this quantity, 40 factorial divided by 3 factorial 10 factorial. I want to call this. So what I will do, I will write this 100 times. I will write this code 100 times. No. What I can do, I can use find underscore. So see, when I wrote find underscore, it automatically show it in a suggestion. So I just need to press the arrow. Let's say I want to calculate 40 factorial divide by 10 factorial into 3 factorial. Okay. And I'll just run it. So see, it is showing some huge answer 3.7474 into 10 is to 40. Let's check this using our MATLAB inbuilt command factorial of 40 divided by factorial of 10 into factorial of 3. And I'll just press enter. So see, we are getting the same answer 3.7474 into 10 is to 40. So this is how we can call our function to find some value. So what did we learn from this example? Can anyone summarize? What did we learn from this example of finding a factorial of a number? Guys, can anyone do it, please? So we first calculated the factorial. Yes.
Yeah, we learned to how to code it in the factorial of a number in MATLAB.
Yes, but what did we learn by using that? We learned how to use while loop, correct? Then we
Yes.
learned how to use
Else if
what else if, then or loop.
yes.
Then what did we learn? We use inbuilt MATLAB command factorial. And then one most important thing that we learned is use of function. How can we use the function and how can we simplify our complex codes? Okay. And we also learned how we can modify our code by implementing more and more situation to make our code more and more general. Okay. So did you understand how we do it, how we did it? And can you write it by your own if you have to write? Okay, I assume you guys
Yes,
can
yes, we can do
do.
it.
So this was really one easy example of finding the factorial of a number. So sorry guys, again, just give me a minute. I'm a bit sick, so I need to stop in between. Are you understanding what Parag sir is teaching you? You are, I guess, at week 3 now. Are you guys, any one of you having any background of MATLAB, or anyone already know how to use MATLAB? Don't worry, I'm not going to ask any questions. I just want to know. And I assume that all of you or most of you are BTech students only. BTech third year or final year, most probably. So this was our first example of finding factorial of a number. So now let's move ahead with ordinary differential equation. These also you don't need to worry about writing part, but I am just showing how we can do this. So for ordinary differential equation, let's say I want to solve this equation dy by dx is equal to x into y, and initial condition is given as when x is equal to 1, my value of y is equal to 1. Yes, my value of y is equal to 5. So can anyone tell me how we can solve this ordinary differential equation? Dy by dx is equal to x5 and y of 1 is equal to 5. And let's say I want to solve it from 1 to 2. from x is equal to 1 to x is equal to 2. Let's say in interval of 0.1. So we have some numerical methods available. Euler method, RK2. What is RK2? Full form of RK? Does anyone know?
Runge-Kotta method.
Rangekutta method of order 2 and order 4. And ODE45, that is solver that is available in MATLAB, and we'll plot it. So let's say before doing anything, how can we solve this using MATLAB inbuilt library? So what I need to do, the command to solve that equation is dsolve. Okay, I'm telling you what is the command dsolve. So let's search it about dsolve. Yeah, it is dsolve. Why it's not showing dsolve? Wait, it's available dsolve in MATLAB. See this dsolve. Did we write something different? D as well. We know we write it correctly. Dsolve. No, it's not showing. I don't know why it's not showing here. Let's see here. We can see dsolve. So using this S is equal to dsolve. In bracket we need to write equation, or we need to write equation comma condition. Okay. So for that we need to use this SYMS, that is symbolic. So let's say my equation here, you can see that equation is dy by dt is equal to a into y. So they have used symbol as y and a, and they have written equation as when it's my differential equation, what will be my equation? Dy by dt is equal to ay. So they have written differential diff y comma t. So what does this diff y comma t means? It is dy by dt that is equal to a into y, and we need to solve it. So I wrote s is equal to, they wrote s is equal to dsolve and equation. Similarly, it's a second order equation, so you need to write y comma t comma 2. So it will understand it at d square 2 by dt square. Let's try to solve this example first. D square y by dt square is equal to ay. So what I need to do here, all CLC. So I will call, let's say dy by dt, right? So y comma t. Oh, I have symbolic math tool. It's not showing it. Just a minute. Oh, I thought I had symbolic math tool. Okay, I have changed my laptop. So that's why it's not. Just give me a minute. Okay, it will install. Just give me a minute. Yes, it will. I will have to close the MATLAB app. Has been closed. This is how you can also install something that is not available in your MATLAB account. I have not, while installing my MATLAB, I only choose basic MATLAB. I did not choose anything else. So this thing didn't come. It was in my earlier old laptop, but recently I have changed my laptop. So here I have not installed that. Which version you are given for MATLAB? Yeah, okay. Okay, it's done. Installed. You can see here it's written installed. So I'll just close this. Okay. So I will write SYMS. Okay, what was our problem statement? This one. I want to calculate d square y by dt square is equal to ay. So what I will do, I will write, okay, let's do it from here. dy by dt. First dy by dt is equal to ay. So what I will do, what are the variables I have? Y and a. So, sorry, not y and a, y of t and a. So when I wrote y of t, it will understand that it is one is y, one is t. A. Yeah. So see, three symbols are taken, A, T, and Y. Now I want to write my equation. So equation is equal to dy by dt. Okay. One thing I want to use. How can we add comment? By using this percentage sign. So my equation is dy by dt is equal to A into Y. So this is my equation and I want to solve it. So what I will do, I will write equation is equal to diff y comma t. So it will take dy by dt y comma t. Dy by dt is equal to ay. So dy by dt is equal to a into y. I can't write ay just. I need to write a into y. Okay, so this is my equation and I want to solve it. So I will do s is equal to, what is the command? Dsolve command. Dsolve of equation equation. Just dsolve of equation. So see, it is showing me that my solution is dy by dt of is equal to ay. My solution is c1 into exponent of a into t. Let's say my equation is minus ay. So what will be the solution? Can anyone tell me? My a is negative. My solution will be exponentially decaying one. So see, it is exponent of minus a comma a into t. Now let's say my equation is second order differential equation. So what I need to do, the same equation, but I need to put one 2. So it will say that it is my second order differential equation. Wait, I just want to check something. F y comma t comma 2. Does it show it? No, it doesn't. So we need to write it like this, comma 2, and I need to use this. You can just place this up key and you can see all your commands that you have used. Please enter. So see, I can see the solution is C1 exponent of minus a raised to 1 by 2 means square root of a into t plus c2 into square root of positive and negative. Okay, so this is how you can get the solution. Okay, now say it's one. You are given some condition to find this constant C1. How can you find this constant C1 and C2? If it's your second order differential equation, you need two initial conditions. And when it's your first order, you just need one initial condition. Let's say for this first equation, we need to find solution and we need to find constant and actual solution. So what I need to do? Okay, what was my equation? My equation was dy by dt is equal to ay. So what I need to do when I using this dsolve, so I need to give some conditions. So how can I give the conditions? So I need to write condition CONDITION. Condition is equal to, what is the condition? Y of 0 is equal to 5. So I just need to write y of 0 is equal to 5 and equal to I guess. Yeah, it is equal to, it's not equal to. Y of 0 is equal to 5. So it is assigning value of 5 to y of 0. And then we need to solve this equation. So here while we are solving it, we need to put, see here you can see the syntax of that part. Here it's written as dsolve equation comma condition. So what I need to do, I need to write first equation, then by putting comma, I need to add the condition. So see, EQUATIONCONDITI. Yeah, it was correct. What was this? Okay, I have written the wrong spelling of condition. That's why. Okay, so it is 5 into e raised to 80. So that is my solution. Okay, let's move ahead with this second equation here. there are two conditions, that y of 0 is equal to b and y prime of 0 is equal to 1. So how can we do this? Wait, let me clear the screen. Now what is the modification? Your condition is in this form. Y prime of 0 means dy by dt is equal to 1 when t is equal to 0. So how can we include it? So here my y of t, one is a, y of t, one is a and another is b from this condition. Okay, then I will write my equation. Same way, equation is equal to, it is second order equation, diff of y comma t of order 2. For order 1 you don't need to specify 1, but for order more than 1 you need to specify. Dy by dt is equal to, so equal to what is that value? A square into y. So a square, so I will a raised to a square into y. So this is my equation. And what is my condition? So we have two condition. Condition is equal to, we just need to write down two conditions at once. Y of 0 is equal to b. So my first condition is y of 0 is equal to b. And my second condition is this, y prime of 0 is equal to 1. What is y prime of 0? So d of y comma 0. I guess it will work like this, but I'm not sure. This 2, right? 1. Sorry, equal to 1. No, it's not taking it. It is taking y of t is equal to 1. Okay, so we first need to define what is dy by dt. So dy by dt means diff of y comma t. I am defining this as dy. And I am writing my condition now as y of 0 is equal to b, and this value of dy at 0 is equal to 1. And now I will solve it. I will have to write it like this. Equation comma co and di, co and di ti. Oh, and yeah. So say it's showing me the solution. Not in terms of C1 and C2. So this is how you can solve your equation. Is this clear to everyone? We will not focus right now on coupled ODE. We will see this, but not important for now, as we are just learning how to write our codes. Okay, first tell me, what is this clear to you or not? Using this, how we can use this dsolve command? Students, please respond. Okay, I assume that it is clear to everyone. So let's try to solve our problem. Okay, so our problem was dy by dx is equal to x into y. So how can I do it? Can anyone tell me from this reference? Now my equation is just dy by dx is equal to x into y. Can anyone help me? How can I write this? This screen is open to in front of you. The only part is dy by dx. Right here. Okay, so let me write it down. First equation, I am using comments. Okay, let me go to live script. This better option. So I'm writing dy by dx is equal to x into y. Let's first solve this equation instead of using those initial conditions. So I will call my SYMS of y of x. So it will show y dy by dx. I will write my equation is equal to diff. How did we write it? Y comma t. So here it is dy by dx y comma x is equal to x into y. This is my equation and I want to solve it. So s is equal to dsolve of equatiy equation. Okay, so I'll just now run it. So see my solution is visible to me, that is c1 uh c1 into e raised to x square by 2. Can anyone tell how we can solve it numerically, not numerically, analytically? So see, uh, dy by dx is equal to x into y. So dy by y is equal to dx into x. So integration both side, dy is ln y and this is x square by 2. So y is equal to e raised to x square by 2 into some constant. So our solution is correct, right? Now what we need to do, we need to put some initial conditions. So initial condition is given to us in the problem statement that y of 1 is equal to 5. So what I will do, I will add condition is equal to y of 1 is equal to 5. Okay, and now I want to solve this equation. So see, my solution is 5 into e raised to x square minus 1 by 2. We can check it, right? What is the condition? Y of 1 is equal to 5. So when I put x is equal to 1, I get 5. So 5 is equal to e raised to 1 by 2 into c1. So my c1 is equal to 5 into e raised to minus 1 by 2. So this is my constant. So my solution is y is equal to c1, that is 5 into e raised to minus 1 by 2 into e raised to x square by 2. So this is what we are getting. Okay. So let's say now I want to find my value for different values of x. I want to find my this solution for different values of x. So how can I do that? Can anyone tell me? Let's say I want to find it as problem statement is stating from 1 to 2. So I want to find value of x from 1 to 2, let's say in interval of 0.1. So how can I do it? Can anyone tell me? Okay. So let's say my x is from 0 from 1 to 2, right? 1 to 2 in interval of 0.1. I guess it will not take it like this. I will have to write down my equation. Yeah, it is taking it. So see, what I do, I just took interval of x and I am having this value of s as 5 into e raised to minus 1 by 2 x square by 2. So I just then wrote s. So what it is taking, it is solving it for various values of x. So see, yeah. So no, these are values. No, it has not solved actually. Yeah, it has not solved. So we need to write down the equation. So let's say my actual solution y actual is equal to what is the solution? Phi into exponent of minus 1 by 2 into what is the solution? Into exponent of x square divided by 2. So let's say this is my solution. Now I'm running it. Yeah, okay. I need to put one dot here. I have shown this to you when you are doing. So see why we need to put one dot here, because my x is a vector of 1, 1.1, 1.2, 1.3 like that. So I need to do x raised to 2 by 2 for individual values of x. So when I put this dot, see here, uh, x is equal to 0, 2. Now I want to find x square. So what I need to put one dot before that. So what it is saying, power is my scalar quantity. This x raised to 2 is scalar. So what does this mean? It will do it for individual values of x. So let's say, so see here, you can see that it is, this square is for individual matrix. So that's why we need to put one dot here. So just be careful when you are dealing with vectors and you are doing this scalar operation x square by 2 for individual values. So you need to put one dot. So let's say I'm now running it. So see, I have my y actual. So this is my actual solution. Okay. So can anyone tell me how can I plot it? How can I plot this solution? Plot command. Let's search for plot command. Yeah, here plot. So see what I need to do. I need to write x comma y, and I am only having one plot. So what I need to do, yeah, one more thing you need to be careful. My X is a row matrix, right? It's just one row and n column. So my Y should also be, or Y actual should also be in that form only. Let's say my X is column matrix and Y is row matrix. It won't take that as input. Okay. So, or it will throw error when you are using plot X comma Y. Okay. Okay, error using, okay, not y actual. This is my solution, right? Y underscore actual. So it is x square minus 1 by 2. So it should be exponentially increasing. Okay, so see, this is exponentially increasing solution. Okay, let's say I want to modify my plot. I want to give here one name x and here one name y on the x. So what I will do, I will use x label. What is my x label? That is x, and I need to put it in this inverted comma. Similarly, y label command we will use to give the label of my y-axis. Now let's run it and see what it is showing. Is it showing x and y? See, x and y are written. Let's say I want to give the title to the chart. So I can write title, say solution of differential equation dy by dt is equal to x y at y of 1 is equal to 5. This is a very huge title. Long title, not huge. So see, it has written it. Can I zoom it? Yeah, I can zoom it. Okay, something is happening. So see, this is my solution. So y of 1 was my 5 and increasing. Let's say you can play with these points. Let's say I don't want these continuous lines. I want points like this. So what it will do? It will show my solution points. Okay. Let's say I want both arrows and point together. I guess this won't work. Yeah, it worked. You just need to put one dash, so it will take it with arrow and dash. So this is how uh, you can show your solution. Let's say I don't want this blue line. I want some different color. Let's say it's green. So for green, it is G. I guess it is G for green. No, there is nothing called G. K is for black. What is the issue? Invalid data argument. How can I zoom it? No, no, no. I don't want to print it. Okay, let's open it in help browser. Axis color is somewhere given. Yeah, see here it's about, yeah, here mark width, mark size, line width, and mark color. Okay, just give me a minute. I will. Here. Somewhere it is written, yeah. This K is for black. I don't know why it didn't work. Do I need to put it here first? I'm not sure. Relax. Yes, that doesn't matter. Okay, it's showing some error with this data input. I don't know why. Yeah, now it's not showing. But when I'm choosing one particular type, showing this error. Okay. Okay, maybe it's taking symbol. Okay, this is for color. Okay, it's not able to differentiate. Maybe that's fine. Okay, so this is how you can create your plot and you can modify your plot. Okay, is this clear to everyone? This is just one simple example using dsolve command. Is this clear to everyone? I hope it's clear to everyone. So now let's move ahead. Let's go for Euler equation and let's write one small code. So how can we solve what is Euler's method? Can anyone tell me? Can anyone tell me what is Euler's method? Students, can anyone tell me how can we find solution using Euler's method? So let's say my equation is dy by dx is equal to some function of x comma y. So my solution is given as y of I plus 1 is equal to y of I plus h is interval size into s. And s is defined as s1 plus s2 divided by 2. S1 is my function value at x1 comma y1 or at the initial condition that is given, and s2 is function of x1 plus h y1 plus h into s1. I guess this is what it is. Let's check it. Sorry. Yeah, here. So yeah, this is Euler's method. So see, my solution is this one. Okay, it is y2 is equal to y1 plus h into f of x1 comma y1. That thing s1 plus s2 by 2, that is something modifications. Okay, let's not worry about that right now. So it is just h into f of x1 comma y1 or xi comma yi. So how can I convert this it into code? Can anyone tell me? Okay, let's write down one small code. I have already written it. So let's put one. Okay, first clear all CLC. Okay, I will just add one comment. So divide by dx is equal to x, y, and y of 1 is equal to 5. Okay. And let's say my I'm taking x from 1 to 2 in interval of 0.1. Okay, so what is the length of this vector? How can I calculate length? So I just need to put length of x. Let's say this one, let's say a is equal to 1 to 2 in interval of 0.1. And I want to calculate how many entries are there. So I will just use this length command, length. So length of a will give me 11. So there are 11 entries. So okay, we'll do that later. And what should be my interval? Interval should be, let's say interval is my, what should be the interval? It should be, okay, let me just run this part. So it will be, you will understand. So see my x is 1, 1.1, 1.2. So what is my interval? 1.1 minus 1, that is 0.1. Correct? So my h will be second entry of x vector minus first entry of x vector. Correct? So it will be x of 2 minus x of 1. You can also do it manually, but let's say if I am changing it from 1 to 0.1, so you will have to change your value of h. So instead of doing that manually, let's write this h is equal to this equation, x of 2 minus x of 1. So when we change the interval, when we change these values increments, it won't affect our h. Okay. So for Euler's method, I'm giving one comment. Okay, when I give double comment, it will create one different section. So it is showing it like this. Wait, I will show you again. Let's say if I am doing just one comment, it won't show it anything like that. But let's say when I'm doing double commenting, it will show it in S section. So this is really good to differentiate to when you are having multiple methods in one code. So this one is easier to understand using double comment. So what is the equation of Euler's method? Y of I plus 1 is equal to y of I plus h into f of x I y I. So what is my function? Equation is x into y. So x of I into y of I. Okay, this is my equation. Now I need to run it from I is equal to 1. So for I is equal to 1. So when I is equal to 1, it is x of 1. So x of 1 is 1. So from I is equal to 1 to till length of the vector x. So till length x. I will run this and I will put n. So let's try to understand what we did. We first defined x is equal to 1 to 2 in interval of 0.1 and value of h. And let's say I'm saying that for I is equal to 1 to length of x. So how many, whichever, let's say there are 11 entries here. So 1 to 11. So what it will do, my I is 1. So it is y of 2 is equal to y of 1 plus h into x of 1 into y of 1. So we have defined y of 1 is equal to 5. We have not defined it. So we need to give it as y of 1 equal to 5. So what is it is now it is having y of 2. It will go to here. I is equal to 2. We will get y of 3 is equal to y of 2 that we are already having plus h into x of 2. X of 2 is 1.1 into y of 2, whatever we calculated in previous step. So this is what we can do. Now I'm running it. So see, this is my solution. Okay. Can anyone tell me why I'm having 11 entries in X and 12 entries in Y? Can anyone tell me? So when I am at I is equal to 11, so what it will do, it will also calculate it for when I am at I is equal to last entry, I is equal to 11. So I is equal to 11 means Y of 12 and we really don't need it. Correct? So what we can do length of X minus 1. So it will be showing 11 entries. We don't need length of X minus 1 like this. I will have to write X. Yeah, so see, we are having 11 entries. So let's plot this X comma Y. So see, I am having this solution. Let's do one thing. We are already having this actual solution. So let's try to combine these two. Okay, let's do one thing. Let's call this Y underscore Euler. Oh no, it will create huge mess. Okay, but let's do it. Y underscore Euler. I don't want to do it for all methods. Okay, let's do one thing. The matrix Y, because X is same for all methods and Y is only different. So let's do one thing. Let's define Y underscore Euler, this Y matrix as equal to Y. So after this loop ends, it will store as whole Y loop in Y underscore Euler. So let me write down here analytical solution. So see, this is my analytical solution. Okay, let's plot it in different section. Plot. Okay. So here in plot. Okay. So here what I need to do, I have two solutions. I have two plots. So how can I add two plots in one graph? Can anyone tell me? Sir has taught this. How can I add two plots on one graph? Anyone? Kiran, do you know? That is using hold on command, right? So let's first plot x comma y underscore Euler. Then hold on. ny underscore actual. And let's say I need to give legend. So legend, first one is my Euler. So I just need to write it in one order, Euler. And my second one is actual, analytical. Okay, now let's run it. It should show some error. Okay, we are correct. No, it should show some error. Yeah. So see, let me zoom this plot, but let me open this in window. So see, there are significant differences between these values, actual values, analytical results, and results predicted by Euler's method. Okay, let's do one thing just to differentiate it. Let's say this is 0. I'm just putting one zero symbol, so it will show that these are points by Euler's method. So we can see that there are significant differences between Euler's method and our actual analytical solution. So can anyone tell me how can we reduce this gap? By stating that I don't want to change the method, I want to do it with Euler's method only. So can anyone tell me how can I improve my solution? How can I improve my solutions using Euler's method? Can anyone suggest me? What is that one factor that governs our solution? Anyone?
By using Euler's modified method.
Sorry, I did not follow.
By using Euler's modified method, improved method.
No, I don't want to change the method. I don't want to change. I just want to keep Euler's method and I want to improve the solution. So what we can do, we can change our step size. It is 0 0.1. That is really a small number. Really 1 to 2, it is just 0 0.1. So let's try to do it with 0 0.01. And let's say, so it is calculating more and more nearer points. So it will slightly improve our accuracy.
Accuracy.
Let's see what it is doing. I'm not able to show my, no, this is previous graph. Wait, let me rerun it. Okay, let's wait. No, it is showing some error. Okay, it is the issue here. I don't know what is the issue. Yeah, okay. Here. Okay, here also let's take 0 0.01. So we will have exact curve. So these x and y both are of same length. So that is the issue. This is not going to affect anything because this is the actual solution. So see here, there are many points. Let's remove this point. Let's remove this so we can clearly see. I don't want to see these points right now. So see, by increasing the value of, by reducing the value of h, by reducing the value of h, by keeping small steps I see, this difference is extremely small, but still there is some difference. So what you can do, you can change the method or even you can reduce this gap from 0 0.1 to 0.001. Here, if I am doing 0.7, it's not going to affect anything because this is the actual solution only. The accuracy is here because from first point we are calculating second point, third point, fourth point in Euler's method. So if we are taking more and more intervals, it is taking more and more points for calculation and it is increasing accuracy. Let's see if we can see the graph. So see, it is identical, right? Analytical method and Euler's method. So sorry. analytical methods and Euler methods are identical. Am I right? Can anyone please respond? When it was 0.1, there was a significant amount of gap. When value of h was 0.1, there was significant amount of gap. When I did it from 0.1 to 0.01, the gap reduced drastically. And when it is 0.001, so see, you can see that there is no gap one can see. There is extremely small gap that we can actually ignore. It's not significant. The gap is actually really small. So it is always advisable to go for smaller step size for accurate prediction. Let's say even if I'm giving more, even lesser number. So what is the one disadvantage of reducing step size?
We
You
will
can see
get
it on.
the accurate answer.
No, disadvantage. Disadvantage I'm asking. You're correct that by reducing step size we will get accurate answer. But see 0.0001. So see you can only see red cow. So what does this mean? That red cow is completely on the top of blue cow. So there is no difference between analytic and an Euler. So it is always advisable to smaller number of size. Okay, so say what is the disadvantage? It was clearly visible on your screen. Let's say I took 0.1. So what happened? The solution
So
is
deviate
oh,
from the real value.
wait. 0.1 here. Both the ways it is 0.1. So my solution is here. Sorry, you were saying something, Rohit, I guess.
Yeah,
Sachin.
answer
Sachin.
will be, the answer will more deviate from the real value.
No, when we reduce the step size or accuracy is increasing, right? So it is not deviating. It is getting real and real, or it is getting actual with analytical solution. But what is the disadvantage? When I am reducing my step size, it is increasing my computations, right? What was earlier case when h was 0.1, it was calculating from 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9, and 1. Only 10 or 11 times. But when it is 0.0001, let's say it is 0.0001. So how many times it will compute it? 0.0001. Let's see how many times. What is the length of that vector? X and Y vector. Let's see. So that length is extremely higher. 10,001. So it is calculating 10,001 times. So what is actually happening? Our computational load is increasing by reducing the value of h. So actually this is really a small equation x into y. So it won't affect here. But let's see if you are dealing really with a really big system, it will affect on your um, speed of the code. So it is better to go with some optimal values of h. Okay, so this is what it was with Euler's method. Okay, let's do it for where is my pen? Yeah, let's do it for RK2 method. So how can I do it for RK2 methods? What is the equation for RK2 method? The earlier one that I showed, right? S1 is equal to f of x1 comma y1. S2 is equal to f of x plus h y plus s1 into h. S is equal to s1 plus s2 divided by 2. And my solution yi plus 1 is equal to yi plus h into s. Okay, so let's try to code this thing using RK2 method. So I am commenting it, double commenting, so it will method. Okay, so what was the equation? S1. It is the same thing, right? Let's first copy this. I just need to modify this part, right? So here instead of Euler it is RK2. S1 of I is equal to, what is it? X1 comma Y1. So X of 1 into Y of 1, and my, sorry, S2 will be X of, X is X I plus H. Let's check from here only. X plus H. So X is my X1 plus H. X of I plus H, X into Y into Y is my X of I plus H, and Y of I plus, instead of Y, what I need to write? This thing into H. Okay, this is my S2, and S is equal to 0.5 into S1 into S2. Okay, this is the thing that I have written. And okay, there is showing some error here. Okay, I need to close this bracket here. So see here, you can read usage might be invalid. So this bracket is invalid. So I have closed this, but I have not opened this. So I need to put it like this. Okay, so let's use the smart indent here. Yeah. And here in plotting part also, let's add with hold on command. Sorry, plot x comma y comma uh, x comma y underscore RK2. Okay, and hold on, and legend I need to put here after Euler. Second is for RK2. Okay, in my step size, let's keep it to 0.1 and see what RK2 method is giving for 0.2 length. Okay, I hope it does not show any error. Yeah. Yeah, these colors are really same. We can't actually, at least I can't differentiate. So let's do one thing. Let's give RK2 in black. So I'm just writing key. I can't differentiate. K is for black color. Okay, so blue and black are coinciding, right? Yeah, this is analytical solution, and this is my solution using RK2. So it's not improving with 0.1. Am I correct? Or did I do any mistake? Hmm? So here it should be I plus 1 as far as I know. but it's not going to affect anything actually. Yeah, so whatever we are getting, we are getting. So just wait for this to run and then let's see how we can improve our code. Yeah, so this is what we are getting. So, okay, I need to know one thing from your side. How can we improve our code in terms of writing part? How can we improve it? Can we use something that I already taught you today for factorial part? Instead of writing this whole function, whole equation x into y every time, it is just x into y, so it's not any affecting a lot in writing part. But can I improve it? So yes, I can improve it by writing it in terms of function. But I'm whatever function that I am saying, it's not something that we learned earlier. That function something is equal to that. I am writing it in different way. So this is one more way of defining equation. So I am writing f is equal to x. What is my equation? X into y. X into y. So I can write f is equal to x into y, and I can put at the rate x comma y. So this shows my variables. So this is how I can define my equation. So instead of here writing x of I into y of I can just write f of x of I comma y of I. Okay, let me show you it here. F is equal to at the rate of x. Let's say it's just x square minus 5x plus 3, sorry, plus 3. This is my f, and let's say I'm calling f of 2. So it will just give me the value at 2. So this is how I can define my, this is not actually function, but this is how I have written my equation. So this is one simpler way, and equation is simple, x into y, so it won't really affect here, but it's better to write it down. What was that? Yi plus s1 into h into h. Okay. Okay, so now let's say I want to write it for RK4 method. Does anyone remember what was the equation for RK4 method? Okay, so for RK4 method, we have two additional variables. Okay, RK4 method, S1 is equal to f of xi comma yi. So my S1 is correct. S2 is equal to f of x1 plus h by 2 y1 plus h by 2 s1. So it is not h but h by 2. 2. Here also h by 2. Then my S3 and S4 are obviously newer terms. So I need to add my S2 and S3. Are you understanding? No one is saying anything. If you are not getting something, please stop me. I'm just modifying S3, S1, S2, S3, S4. And S4 is, what is S4? I guess it is just X1 plus H. And okay, yeah, Xi plus H and S3 into H. Yeah, and this is S is defined by S1 plus 2S2 plus 2S3 plus S divided by 6. So it is S1 plus 2 into S2 plus 2 into S3 plus S4 divided by 6. So see here, there is something red. There is one error here. Okay, so I will not close this bracket. Also, I can just write this thing. And what is my equation? It is simple h into s. Correct? Yes, so see here it was this issue. It was h into s of I. So that's why we are getting same answer. Okay, first let me do one thing. Let me comment this part. I just want to see what we are getting with RK2. Here it was the issue. The equation is h into s. So here I need to put s. Yeah, but it is the same thing only. Oh yeah, it won't matter. It won't matter. Okay. But let's see. S of I and f of xi yi is same thing only. So it is same. So RK2 is also not showing good results with a 0.1 step size. Oh, what happened? Just a minute. It is something with x values. And yeah, here it is S1 plus S2 plus. It's not multiplication, correct? So that is our mistake. Just let's see what we are getting with RK2. Yeah, see, RK2 is black one and black one is really coinciding with analytical solution with just step size of 0.1. See, RK2 is coinciding with actual analytical solution, but still there are small gaps and that can be overcome by if we take from 0.1 to 0.01. Not like Euler that we need to go till 0.0001. So RK2 is well matching. Now let's add RK4 and see. RK4 will be more accurate. There are still some discrepancies at higher side. So let's add RK4 here. RK4. Are you understanding or not? I'm assuming that you are understanding. Hold on. And let's say RK4 is in which color? Green. G. Let's see. See, green we can't see it at all. So green has already coincided well with RK with analytical solution. So what did you learn from first thing? Anyone tell me what did we learn first in terms of numerical methods from here? In terms of numerical methods, Euler method, RK2 and RK4. What did we learn? We learned that when we are doing Euler's method uh, to get uh, to get actual solution or to get closer with the actual solution, we need to have really a reduced step size, really a small number of step size. When with RK4, even with step size of 0.1, it gave accurate prediction. So a RK4 method is really accurate method with we can take small amount of we can take h is equal to only 0.1 for our particular system to get accurate solution. In terms of coding part, what did we learn? We coded all these three methods, RK2, RK4, and Euler method. We learned how to plot it, and we just learned the small thing of defining equation and calling it everywhere. Instead of writing a function, we just wrote it like this. This represents my equation. So this is what we learned from today's problem. So did you understand what I taught you today? One was for factorial of number and second one was differential equation. You don't need to worry about coding part for now, but I hope you understood what I did. So you have idea if you have to do it by your own. Okay, let's take some small. We have only 10 minutes left, so let's try to do whatever we can in last 10 minutes. So this we have done. OD45 we will not do it right now because it's not required. We will solve it when there is one whole week for ordinary differential equation. At that time we will solve. We will use this OD45 method. Okay, so this is my question. Consider an array A comprising of two elements. Compute the output file of summation of cosine of the first element and sine of the second element. So what I need to calculate? My A is equal to 15 and 25, I guess. Yeah, it is 15 and 25. So what I need to do? Cosine of this plus sine of this. So what is this? 15 is my first element. How many rows are there? One row and two column. So this is 15 is my A of one row, first column, and this is my first row, second column. So I need to find cosine of first row, first column element plus sine of first row, second column element. So how can I do it? I just need to write it down this thing. My A is equal to 15, comma 25. Uh, Cosine of which element? A of 1, comma 1 plus sine of B of 1, comma 1. 1, comma 2, sine of A of 1, comma 2. It is A matrix only, right? So I'm getting minus 0.8920. And actual answer is minus 0.8920. So is correct. Did you understand? Okay, the second question is consider the following code and identify the correct option to print the last statement of the resulting array. So my n is starting from 1 to 9 in intervals of 2. So it is going it like 1, 3. So see, what does this mean? It is going 1, 3, 5, 7, 9. And my a of n is equal to 2 raised to n. So first it is printing 2 raised to 1, 2 raised to 3, 2 raised to 5, 2 raised to 7, and 2 raised to 9. So this is my A matrix. And what is asked? To print the second last element. Which one is second last element? This one is my second last element. So how can I print my second last element? First row and 1, 2, 3, 4, 5, fourth column. But here, if we don't know the column name, we can use AND command. So it will AND is my last column. So it is first row and AND minus 1 column. So what should be the answer? Answer C. Right? Let's do it here and cross check it. A is equal to, sorry, it's taking time. I'm sorry. A is equal to 1, 2, 9, 4. Let me put one semicolon. 4. N is equal to 1, 2. Sorry, what was that? I forgot. Okay, 4 N is equal to 1 to 2 to 9. Sorry, A of n is equal to 2 raised to n. N. So I want to print second last element. So what I want, I will write this. Display of matrix is and minus 1 because it's a row matrix. So we don't really need to write a of 1 comma 1. So let's see if it's printing 2 raised to. No, it's not printing. Wait, let me do one thing first. Yeah. Now let's
You are
run
not.
it. Sorry.
You may not provide the number of rows.
No, it's not this. Yeah, it is getting 0. Yeah, okay. Second last element from 1 to 9. Okay, no, it's not the issue with row C. Okay, my second, fourth, sixth, and eighth element is coming 0. It's not, what do I say? Because we have given is, let's say I'm giving is 1 is to 1 is to 9. It will print 256. So it is actually printing second last element only. But when we are doing it like this, so as we have 1 to 9, so as we are having 1 to 9, but we are going in interval of 2. Yeah, what was the issue earlier? I did not understand really. 1, 3, 5, 9.
7. 2 to the power 7 is not the 0.
Wait. I'm sorry. 4n is equal to 1 to 9 in intervals of 2. So it should take it, right? Wait.
1 equals to
1, 3, 5, 7, 9. Okay, let's do one thing. Um, yeah, but we are getting the correct answers, right? Because it is the second last element, 256. So it is second last element. So that is uh, end of, let's say if you are saying 1, I am writing 1 comma. So then also it will show me that answer only. Because it's just one row. No? So it is this. I don't know initially why it showed 0 zeros. Okay, so this is also clear. Let's go to third question. Okay, this is already 45. Will not solve it right now. Question 4. Use appropriate inbuilt functions to return the trace of inverse of matrix A. Okay, what is trace? What is trace of a matrix?
sum of the diagonal elements.
Yes. So let's first write down the matrix. Sorry. A is equal to, okay, let's do it here only. A is equal to 1, 2, 3, 4, 7, 8, 10, 5, 6. 1, 2, 3, first row, then semicolon. 4, 7, 8, semicolon, and 10, 5, and 6. Okay, so how can I find the trace? First, what I am supposed to do, trace of inverse of A. So first I will find inverse of matrix A. So to find inverse, I need to write INV. So see, INV of A. So it will give me inverse of a matrix. Now I need to find trace of that inverse of matrix. So I will use trace inbuilt function trace. So trace of inverse of A. So it will give me 0.6389. What is the whatever is the trace of that matrix? Okay, let's say I want to find trace of transpose of inverse of A. So how can I find transpose? I can write transpose. Transpose is also straightforward. Transpose of A. It's like this. It is coming same. Wait. Let me first check transpose of A. And okay, yeah, it's coming same. That is just coincidence. 0.6389. Let me just change this value 5 to 1 for now.
Is there any formula for determinant of A?
Yeah, it is coming same. Yeah, because in transpose paths, rows are converted into columns, but that middle element will be there only. It will be in middle position only, and endpoints will be end only. So it won't matter if we are taking transpose or not. Yeah, good point. Okay, so let's do one thing as we are out of time. I will just take one last small question that is related to your assignment. We will do this next week. Where did that question go? Cat and dog. Yeah, this question number 14. What is the output of the following command? Let's say I am writing, this is something related to your assignment, that's why I'm showing it to you. Let's say my A is equal to, I am writing it in this inverted comma, 1 space 2. So what it will show me, it will show me two numbers together as 1, 2. So let's say if I am writing Tom and Jerry, Tom and Jerry, what should I get? Everything together, right? Tom and Jerry. Let's say I'm
Yeah.
putting one space and before Jerry, I am putting one space. So it will get Tom and Jerry the way we have written. So let's say what should I get here for question number 14?
C.
What should I get for question number 14 as output? Can
C.
anyone tell me?
Option C.
This question is related to your assignment. That's why I'm showing it. What should you get if I'm writing it like this? So see,
Option
if
C.
it was like this, Tom and Jerry. So what it was doing, it was showing everything. Whatever is written, it is showing everything in ones. So here also what it will happen, we have written cat, mouse, and there is no space in this inverted comma. So it will show this thing, cat, mouse together. Okay. So thank you everyone for joining. That is all from my side for today. Whatever questions are left, we will discuss it for next Monday. And if you are having any query, please feel free to ask. Or you can, as we are already out of time, you can write me an email here if it is related to something related to assignment or something other thing, something other you want to ask me or discuss. Please drop me an email at this ID. So I will respond to you as soon as I can. Okay. So that's all from my side for today. Thank you so much, everyone, for joining. We will meet next week. Until then, take care and enjoy. Bye bye.